Thanks, Jorge, and I know Bob's not here, but I got to know Bob through the gap analysis program, I think about 25 years ago, so kind of date myself there. But I greatly appreciate the invitation. Came down here to work specifically with Bob and Jorge next week and several others, maybe some of you in the room next week on Maggie Island on incorporating managed retreat in this integrated landscape planning work. So I'll talk briefly about that closer to the end, and hopefully everybody speaks American and you can understand me. I am working on my 12 steps of overcoming jet lag, so be patient with me on that. But let's go ahead and get into this. I think Jorge covered my background pretty well. Buried deep in there's a career in landscape architecture as well. I only bring that up because I think that's provided me with ability to really think at different scales. I often see a lot of very big scale work fail to get implemented because people didn't consider how that work it needs to ultimately translate to site level work. So that's something that I always like to bring into these approaches. So in terms of what do I mean by the coastal crisis that was in the title there, I think probably this audience gets it pretty well, but just recognizing that most people live near the coast in the world, a very large proportion do. Sea level rise is putting increasingly, millions of people at risk. Probably eventually we'll have hundreds of millions of people that are going to be displaced by sea level rise. There's always kind of that tongue-in-cheek joke about, well, I live a kilometer from the coast, I'm going to at least have beachfront property pretty soon, but I point out that there is not going to be the funding to remove and restore all of that inundated wreckage in between you and the beach. So we're going to have whole massive neighborhoods and communities of rotting houses sitting there that we haven't figured out how we're going to deal with that. We all know governments are not planning typically to deal with this problem. I know you had a good start in Australia several years ago, and that's been a bit derailed, and of course we experienced the same thing in the US. There's also this issue in the US of just accepting that the government's going to bail out communities when we have these disasters. Come to a slide right after this going into a little more detail on that. But as I say, you have to think about, in the last few years, we've had several major hurricanes hit US states and territories. If we have that going on all the coasts simultaneously, there really just isn't going to be funding to deal with these in a crisis mode of we're going to rebuild everybody's houses for them. And we tend to do that right where they were destroyed in the first place. So they're just setting it up for the next disaster. A lot of this crisis then is driving what I call stopgap measures. Let's quickly throw in a seawall or a lot of sandbags, some kind of hardening of the coast, which just, again, tends to amplify the problems and contributes to this concept called coastal squeeze, where we have our coastal habitats, marshes, seagrasses, mangroves, things like that. And we've got sea level rise that's wanting to push them inland, but we have a lot of infrastructure that's preventing that from happening. And then this competition there with my last bullet, sorry for those of you in the back, you can feel free to move up. I have a lot of kind of fine scale maps and text and things in this presentation. But as we do ultimately see land uses needing to shift inland, on the one hand, they're going to be competing with land uses already there, whether that's existing agriculture or lower density development or conservation, which is a land use, or just essentially out-competing the existing biodiversity there. So I think, again, from the US example, when we do have crises, there's an inclination to officially waive all environmental regulations. We're seeing that with the border wall going in between the US and Mexico right now. So I'm not confident then when we have these crises where people at least come to the understanding they need to relocate development further inland, that they're not going to say it's fine to do that on that existing nature reserve. This was just a piece. I've been talking to the Pew Charitable Trust about this lately. They're pretty interested. As you can see, the figure there in the middle of $845 billion in the last 20 years of losses in the U.S. from flooding. A lot of that just in the last few years between Hurricane Maria that has essentially leveled Puerto Rico, and then Hurricane Sandy in the Northeast, Hurricane Harvey, which flooded the Houston area with 50 inches of rainfall. So a lot of the massive multi-billion dollar, tens of billions of dollars of damage just in the last few years. So how do we address this? So I just want to lay out some high-level thinking about the approach to this. And we can start off at the highest level thinking about ecosystem-based management is a well-known framework. In the planning world, we often talk about multi-objective planning. So instead of just straightforward conservation planning, we're really thinking about how to meet human needs along with that, so making that multiple objectives. Nested under that, I think about coastal zone management or this integrated land-sea planning, or the ridge to reef planning. So those sort of subsets of thinking more confined geographically. And then in terms of within that integrated land-sea planning, bringing in the different types of both land and ocean-based threats and stressors, particularly flooding and sea level rise is part of that. When we think about how those threats are going to affect human communities, but also biodiversity and ecosystems, so how we can address resilience against those threats. And then getting more technically, and what I'll be focusing on in a large chunk of this, is really scenario-based approaches that are very data-driven, science-driven. So how are we going to engage stakeholders with that scientific process and data process to develop these solutions, which can include both what's called gray infrastructure, so hard structures where needed, but hopefully primarily thinking about green infrastructure or nature-based solutions. All right, so I've got a sprinkling of photos of typical problems that we see here. So thinking more about this planning framework, and then I'll transition into this technical toolkit. What we're trying to do is address resource management needs across realms. So thinking about terrestrial, freshwater, and marine simultaneously, and how those are interlinked. And then address the stressors across those realms as well. And so we have direct stressors in terms of land use impacting terrestrial-based vegetation, habitats, for example. We also have direct stressors within the ocean, so that might be building some sort of aquaculture, for example, or energy development, certainly oil drilling out in the marine realm. And then we want to think about how those land-based stressors are additively contributing stress. So, of course, thinking about runoff, contribution of sediments, nutrients, other kinds of pollutants into the nearshore marine realm, delivered primarily via the freshwater ecosystems. And then we have what's coming essentially from the ocean, threatening the land-based assets and resources, so sea level rise, storm surges, things like that. Then we're also integrating these ecosystem processes, and so there's often a need to maintain or perhaps even direct or enhance in some way that delivery, particularly of sediment, but nutrients also into the freshwater and marine realms. So one of the things we're seeing a lot in the US is what's called thin set deposition, where we're actually trying to augment the sedimentation within marshes. So they are accreting and growing in elevation to combat sea level rise. But we've often manipulated the hydrology so much that we're not getting the delivery of those sediments. You may have been exposed to news about Louisiana. I don't have the figure off the top of my head, but losing, just miles and miles of their marshes out in the ocean that are then causing that coastline to retreat inland, and then it just feeds on itself and keeps accelerating and then threatening, of course, a lot of infrastructure and communities. Okay, and then we also want to integrate the human side of this. And so again, what we've seen a lot of the barriers in addressing these problems is that we're working across government jurisdictions, across sectors of interest. And so, how can we actually get these different jurisdictions and sectors to be able to work together with their stakeholders? And then finally, there's this idea about trying to communicate through advanced kinds of analyses and integrated planning what those co-benefits and trade-offs are across sectors. And example I give here of what we don't want to see happening is in the US, we give a lot of subsidy for corn production in the upper Midwest. All that sedimentation and nitrogen in particular flows into the Mississippi River. That ends up in the Gulf of Mexico. It creates something called the dead zone, which is the size of a state out there where basically nothing can live. So there's a lot of impacts, both ecologically but also economically to the Gulf Coast, shrimp and seafood industry down there. And that's not something that's really recognized and addressed by this other economic sector, a couple thousand kilometers away up in the Midwest. So, I hope I didn't steal any thunder from something you're going to do. But again, as Jorge mentioned, we've been collaborating a lot on these idea frameworks. So this is pretty new. I think you generated this recently.
Thank you.
Yeah, and so some of the aspects we can see in this, beginning over on the right side with a marine focus on marine species and ecosystems, and a lot of the stressors directly impacting those. But as we move to the left is where we start to incorporate this integrated land sea thinking about catchment models of runoff, plume models out in the marine realm. So how does that runoff express itself and extend out into the marine habitats? And then working our way vertically up there, looking at the sources of that stress in terms of land use decisions, how government policy plays into that. And then there's this one that I developed several years ago that looks very different. This one, in a way, is more generic as a kind of planning process. But again, hidden in the little circle down there at the bottom are these cross-realm processes. So inherent in all of this is thinking about this integrated land sea application, and then at the top are stakeholder processes. So you see a lot of feedback loops with stakeholders there, and then in the bottom right is the adaptive management component of this. So as these dynamic coastal areas continue to change and we learn more, how do we cycle that learning back through this process? So we can translate those frameworks into a technical toolkit. This is where we're talking about software tools specifically. And so over on the left blue box, we have what I consider a core integrated land sea planning toolkit. And I'll talk a bit more about the tool Vista up there, but these are primarily spatial analyses tools. So Vista is really our general assessment, scenario-based planning software. Many of you are probably familiar with Marksan, shown up there, that came out of University of Queensland. So that's doing a lot of prioritization. It was a key tool in helping to prioritize conservation for the Great Barrier Reef. And then the two tools down below are those ecosystem process tools. Primarily we're thinking about hydrology, so NSPECT for analyzing runoff from a catchment, and then a marine plume model. And then all of those tools are sharing a common database. And then there are these specialty tools on the right that are brought into the toolkit depending on what the particular situations are in a catchment or in a community. So things like SeaSketch, which is more of a online spatial stakeholder engagement tool that allows stakeholders to draw their own reserve configurations, for example, and get feedback on it. Community Viz is a very in-depth planning and socioeconomic tool. SlamView is a tool in the US for viewing sea level rise extent, and then INVEST is an ecosystem modeling tool that I'll talk about a little bit later that we're using on another project in the States. So just a little bit about Vista. So this tool has been around for about 16 years now. You can see several $1 million in funding for it, not specifically developed just for these sort of coastal marine kind of applications, but those icons in the middle just showing breadth of different applications that it's been put to. So this is a spatial tool for the GIS folks in the room. It's an ArcGIS or ArcMap extension. And again, the intention here was to bring fairly sophisticated planning capability to it, but have it be fairly user-friendly to support folks that are planners and managers. They don't necessarily have to be GIS experts or scientists. And then every tool has its circle of circles showing what it's good for, but here we can see at the top there's the process of identifying values and issues. So really, what are you trying to accomplish? Moving on to the right in terms of your spatial data experts and your subject matter experts. So populating a database that the tool is going to run on. And then from there at the bottom, being able to hand that off to the planners and managers to do things like assess patterns of value across the landscape, as well as scenario-based evaluation of conflicts, where you're falling short in meeting your objectives, and then going through iterative processes to develop and test alternatives, eventually ending up with a plan that you want to implement and monitor and do that adaptive management over time. So that's what those other arrows are indicating, is those iterative feedback loops. Looking at that more graphically, we start off with what are called elements. Those are the things that you care about, that you want to assess impacts upon or plan for their viability or sustenance over time. And you have maps and you have values and expert knowledge about those things. We can then combine them in a variety of ways to look at patterns of value across the landscape and seascape. From there, we can characterize different scenarios. So we're usually thinking about a baseline. What is our current scenario? And these incorporate maps of what is currently going on in the land, air, and water, or what we expect to be going on in future, say, trend scenarios or plan scenarios, as well as the mechanisms behind those things like policies. Once we characterize those, we can intersect those with our elements, and then we can get a lot of information back out, both in map and tabular form, of how are our elements faring under any of these scenarios. We can explore those in detail at the site level, and then we can turn this into a planning tool where we can propose mitigations or actions and put those together and build up new alternative scenarios over time and eventually our plan. We can assist that through this wizard that works with MarkSand. So we can optimize spatial solution sets, and then bring this into this more explicit spatial design and policy planning function within Vista. And then overlaying all that is this adaptive management cycles. There's some functions in Vista that make it very easy for you to bring in updates of science or better data sets, new trend information, and then recycle through the analyses and make corrections to your plan. So I won't step all the way through this, but just wanted to show underneath that first high-level toolkit, I show there's these more detailed workflows. And this is really just indicating, again, these different boxes. We have our baseline scenario, we have a trend scenario, we have the interaction with the stakeholders, and then that leading us to a preferred scenario below. So what I'd like to do is show two examples. One is from Puerto Rico, the other one is from Delaware Bay in the States. And so the Puerto Rico one doesn't incorporate sea level rise or threat. This one was really focused a lot more on this integrated land sea planning from a delivery of sediment and nutrients from land-based stressors into the marine realm. So this project was a partnership with NOAA, that's our Ocean and Atmospheric Agency in the States, and the government of Puerto Rico. And it focused on the what's called the Northeast Ecological Corridor. So this is really the marine area off the east coast of Puerto Rico, and these other two islands of Culebra, the small one at the top there, and then Vieques on the bottom. And we've been working with the Conservation Trust of Puerto Rico for many years, so we have a really nice Vista database project for the entire terrestrial side of the island, but in this case, we wanted to add the marine components to it. And I'll just add this, all this technical work was done by an intern. So a graduate student, Samantha Koshishilo, did a fantastic job on this. And there's a more in detail webinar recording on the EBM Tools website for this. So first step is defining these conservation elements of interest. So I just have a few of them up here. We have our mangrove forest, we have coral, we have manatees, we have seagrass beds, and there's a whole ton of terrestrial stuff as well, different forest types and species. So again, we can combine those different maps together. So we get an index like this that goes from light green to dark green. So basically lower diversity to higher diversity. Just because something's low diversity doesn't mean it's not important. It's just indicating where we have concentrations of multiple values. But again, you can see this transcends the land and sea. That big dark blob over there on the left, that's the El Yunque National Forest, gorgeous rainforest remaining there on the island. And then you can see a lot of the other data, a mix of different resolutions. A lot of those big circles are manatee observations, and then the very fine scaled items out there between the islands, that's came from some super high resolution digital videography that NOAA, I want to say flew, but basically the imagery that they towed behind the boats out there at, I think, sub-meter resolution. So it's some really interesting data to work with. So then there's this aspect of how do we really understand these land-based stressors on the nearshore marine. We used a tool called OpenInspect from NOAA. That's a free tool that you can download. I think that works with MapGIS. And what's interesting here, their little graphic, it shows a marine plume. It actually doesn't do any marine plume modeling, so I'll talk in a minute how we got at that. But essentially what it's delivering under any scenario you can give it is what's the water runoff, what's the sediment concentration runoff, nutrients, and some other things like heavy metals. So it's not a super fine detailed tool, but it gives you a pretty decent idea of what is going to end up at the mouths of the rivers and at the shoreline pixels, but also any point on the landscape, how much is coming off of it, which is super useful to understand where most of the problems are originating. Now in the PLUME model, there's actually not a lot of good tools out there to do this. So what Samantha did was she got, excuse me, a hold of this MAURICE imagery. So looking at the plumes in the top there, the MAURICE imagery translates that into relative density of stuff in the water. You're not really quite sure what the stuff is, but it gave us a much better idea than simply a photographic image of the density of pollutants within these plumes. So then what we did is we combined the data from what NSPECT was saying was hitting the shoreline, and then extrapolated that out into the plume itself using the density information from the MAURICE imagery. Would be great to get some actual water samples to back that up, but we thought this was a reasonable approach to trying to communicate that. So then bringing all that information into Vista, this is the combination of within the shore, these tan to darker brown colors of where these sediment nutrients are coming off of the catchments, and then the marine plume out there, which the variation really wasn't enough to show color variation out there, but basically that's the extent of the plume. And then here's combining that with other terrestrial parts of the scenario. So red would be, for example, the urban areas. Yellow and light green are different agricultural uses. Dark green is conservation uses. So this is the complete scenario of land-based activities and the plume stressors. And there's also some fishing out there in those dark kind of purple blobs and some other direct marine uses. So in Vista, again, it intersects that information with our element maps, and then there's a couple different cumulative response models that it's running, and you get results for every element, but this is a synthetic result here across all the elements. So the tan colors are where the elements are compatible under that scenario. The pink to red are where the elements are being impacted. So it's just a richness gradient. So the light pink is where we have one element being impacted. The darker red colors are basically hot spots of conflict where you have multiple elements being impacted. And there's quantification of that. So basically, I think somebody went hog wild and put that into meters, but there's square meters of impact per element calculated. And then the next step of this was wanting to move into the planning realm. So what sort of help could we get directing us into efficient places to work using Marxan? And so again, I think Samantha got creative with this, and we, in a way, we sort of flipped Marxan on its head. And what we wanted to do was start with the marine side. So we ran marine prioritization, and the red areas are all the cells selected by Marxan in what's called the best of runs of where you could efficiently meet your conservation objectives for our marine resources. And then for the terrestrial side, what we wanted to do was focus on those areas where most of the pollutants were coming off of the land. So we essentially set a target based on the highest areas of sedimentation and nitrogen in Marxan, and that directed us to those places. So I'm not sure I'd ever seen an application of Marxan like that before. And then just zooming in, this is going back to the conflict map for kind of that north and east immediate parts of the coast there. So this is the areas of high conflict from the Vista result and the correspondence with the Marxan areas. So basically Marxan saying you should meet your goals here, but us showing that there are impacts that need to be resolved. So again, working with Vista, this little tool here is called Site Explorer. And so we can select areas, so red outline of some cells there in the middle, and we can see what's going on in those cells, the inventory of which elements are there, how impacted they are, and what's driving those impacts. And so what we could see is that we're getting a negative response to the plumes of their both sediment and nitrogen going on. And so then what we wanted to do is just manually trace up the watershed. Where do we see a lot of that pollutant coming off of? So that red blob in the middle is an area that we defined that has a lot coming out of it. And so in Vista, we can say we want to apply an erosion control mitigation there. We could then send that activity back into NSPECT, and then NSPECT would rerun that result. And then what we can see on the left is the original NSPECT. Again, the brown blobs through there are where you're seeing high concentrations of sediment. And then the model of showing that essentially mitigated on the right. So we're not going to have nearly as much sediment coming off. And then we could feed that back in. And I just have to apologize for these maps because they look identical. But on the left, it's essentially showing the original amount of sediment coming off in, I think it's a milligrams per liter measure. And then on the right, you can see that it's reduced, not reduced enough for us to mitigate all the impacts, but that really was just giving one test for one mitigation. So essentially, you would just repeat that activity until you see your plume concentration drop enough and your viability of your elements come up, and then you can add that into your action plan. Okay. So moving on to the next example, this one didn't delve a whole lot into, the concentrations of sediment coming off the land. We got into that a little bit on this, but this one really focused on the stressors of flooding threats, both on the human communities and their assets, as well as the biodiversity. and how could we combine that information to direct people to do conservation and restoration of the biodiversity areas in a way that would improve the human community resiliency. So this project had a lot of partners. The National Fish and Wildlife Foundation in America was the key partner on this. A university lab, NEMAC, NOAA, and the U.S. Army Corps of Engineers. And then NatureServe, my former employer, was the lead on the work that I'm going to be showing you. So this project had two scales. All of the coastal catchments shown on the eastern Gulf and west coasts were assessed at a course level by the university lab, NEMAC, and then those light blue blobs are what's called the targeted watersheds. Those were the ones that NatureServe did a very in-depth analysis and worked very concertedly with hundreds of stakeholders in these different watersheds over a couple-year time period. So the objectives, basically, I covered a lot of this, looking at both human community resiliency and the fish and wildlife habitat, how we could account for both the storm surge and sea level rise, but also precipitation caused flooding events. That made this project also somewhat unique. And then again, how can we build this idea of mutual resiliency between the ecological side and the human side. Many different products came out of this, key ones being reports, the actual spatial data that was gathered as well as the outputs, the decision support system that allows people to apply this work, and then a series of webinars and outreach products. And so all this stuff is up and publicly accessible. So there's a website where people can get at the reports, they can download the data, they can download the Vista software, and so on. And then, like I said, there's other things like recorded webinars that they can watch. And then there's this coastal viewer that NEMAC put together. Only a few of the targeted watershed key layers are on there, and they coarsened it up from 10 meter to 90 meter. But it's a free and easy thing for people to use. So out of those 7, I'm just going to focus on one, the Delaware Bay. And so just geographically, you can get an idea where that is on the East Coast. Pretty large estuary there, and the area immediately around it is fairly rural and agricultural, some forest, but upstream you have big cities like Philadelphia contributing a lot of stuff into the water. So again, with Vista, we gathered several different conservation elements, and this is an index. That curious line running down the middle is showing the differences between data between New Jersey in the north and then Delaware on the south. And so, just a difference in some richness of data available. This is comparing a model of how condition weighted into the richness affects those. So on the left is just richness, on the right is condition weighted richness. So how good a condition are those in? And again, you can see, some effects from the cities, fairly low condition, the further up the watershed you go. And then we get into the conflict map or the viability map. So this is where we assessed different scenarios, but looking at the baseline situation. And again, the red is where we're saying that there'd be a lot of heavy impact to the biodiversity. And I think that previous one was that one was the baseline, and then this is the one with all the flooding threats and sea level rise. So you can see sea level rise is expected to have a lot of impact on the biodiversity. And then we've got the human assets. Those don't tend to overlap a lot, but this one was against all of the flooding and sea level rise. So again, all the pink you can see fringing the bay would be impacts pretty much everywhere. So from there, we combined all of that data together, and what NIFWF wanted to accomplish was mapping what they call resilience hubs. And so we have these 100-acre units throughout the different, throughout the whole watershed. And so the light green are basically, yellow and light green are lower scoring hubs. The dark green to dark blue are very high scoring hubs. And all that means is essentially those are, the high scoring would mean that there are vulnerable human assets or populations there. There is a richness of biodiversity in those. And then there are opportunities to do conservation and or restoration that would improve the quality of the habitat, as well as, again, hopefully add some buffer, some resilience to the human communities there. How am I doing on time, by the way? About, okay. I'm approaching the end. I think we're in good shape. So one thing I wanted to point out that was kind of interesting about this, maybe I'll just walk around here, make it easier to point out. So this is Cape May, New Jersey, very, very popular tourist area. We have these big coastal watersheds and ponds. You tend to think you'd want to concentrate your resilience activity here because you have hurricanes coming and slamming into the coast and overwashing this. You're seeing most of the higher scoring hubs on this side. Often what happens in these constrained bays is that storm surge comes in here. You have a backup of floodwater from really intense rainfall. That combines, and oftentimes the worst flooding actually comes from the inland side here, and then wipes out those towns from the opposite direction. Okay, another part of this was gathering from the stakeholders existing plans or ideas about resilience projects they wanted to do that explicitly had that dual benefit in mind of biodiversity and human resilience. And so one of the things we were able to do where they had footprints for those was intersect that through all of the analyses we had done and then be able to characterize those projects. And the reason NIFWIF wanted this was after Superstorm Sandy hammered the northeast coast of the US, there was a lot of money thrown at that problem, and they had this immediate need to put that into action to rebuild sand dunes and beaches and restore wetlands. But they had no idea where to start. No one had really done a prioritization of that. So what they wanted to do was have a database that hopefully proactively when they got money, but could also be reactively to know which attributes of these projects for any particular need would be able to prioritize them, and they could put some money into those very quickly. So a little bit about some work in progress. Following that up, I have a partnership with Duke University, funded by the Climate Alliance, and we're going to be working on states from North Carolina in the south up through New York State, and very similar aims of this mutual resiliency, but this one's going to focus a lot on what's called blue carbon marsh restoration. So the idea is that salt marshes can actually sequester a lot of carbon in them if they're managed properly. What we've done historically is disconnect a lot of those marshes from tidal influence. And so that actually ends up releasing a lot of carbon. And so if you can reconnect those to get that tidal influence, you can start accreting sand and sediment in those, and that's what kind of buries the carbon as the marsh grows and gets taller. And they're going to be using the INVEST software to be doing that ecosystem service modeling. And then, I mentioned the other work I'll be doing here, next week, and hopefully continuing on with ARC Center. So really thinking about this managed retreat aspect of integrated land sea planning. And I think this is really important because as we've been doing a lot of literature review, there's increasing body of work on the socio-political and economic aspects of managed retreat. There's not a lot really on the ecological aspects of that. And so there's a natural fit, I think, with integrated land sea planning frameworks we've been developing that are naturally aimed at integrating human needs with nature and how we add managed retreat into that. So I've been having some good discussions with folks at Stanford and Columbia and Harvard and some foundations that are pretty keen to help us with that. So this is just going back to that same framework I showed earlier in these little boxes, just a bit of a mock-up at this stage, but just indicating those places where managed retreat should probably get some very explicit consideration in that framework. And then again, I don't think I've shown you this one yet, but this is just, again, some very early thinking about more localized action. And so on the y-axis, thinking about what's the imminence of threat, and most explicitly thinking about sea level rise. And on the x-axis is the severity of loss of stuff that a community would care about. So of course the human assets, but also their natural environment. And so, you know, where things like managed retreat would fit in on different time frames and imminence of threat or severity of threat. But also these other tools that you have in terms of not giving people money to rebuild in the exact same place where their house was just destroyed. You know, in some cases recognizing that shoreline hardening probably is going to be necessary to protect really high value assets, but also where these natural adaptations would be a better solution. So just a few conclusions. One is that technically we know how to do this. We have increasingly good data to do this and good models. Some of our colleagues put out a paper fairly recently, really delving into the modeling aspect, did some fantastic work on that. So it's really not really a technical or scientific problem, not saying there's not always more to learn, but we can be doing this right now. Really our most significant challenges, again, I think as this audience knows, is the political will to do this sort of assessment and planning. That's very closely tied to landowner, I should say probably lack of acceptance and willingness to participate in this. You know, people are just scared to death. This analysis shows that their property's going to be worthless, you know, within the life of their current mortgage. In places like Florida, that's a very scary thing. And of course, then just finding support to both do the analysis and planning, but then to actually take action on this. And this gets at the problem I brought up at the beginning of when we have sea level rise as a slow-moving disaster on every coast at the same time, where's the money going to come from to deal with that? If we start spending now to help communities deal with the most imminently threatened places, we'll be able to hopefully get a bit more ahead of that curve. So with that, thank you for your time and attention and the invitation to come and give this talk. Happy to take any questions. I have a couple for you from me, if anyone cares to tackle those, but thank you, appreciate it.